Hello, and welcome back to the Rawkode Academy. I'm your host, David Flanagan, also known across the internet as Rawkode. Today, we are taking a look at a piece of open source tools to help simplify and flexify, words I've just made up, your Kubernetes deployments. Today, I'm joined by the creator and maintainer, Alexander. Hey man, how's it going?
Hi, thanks for having me. I'm good. How are you?
Yeah, I'm doing very well. I'm always excited to see a new tool in the Kubernetes space, especially when I'm not entirely sure how to pronounce the name. But today we're taking a look at Kluctl, Kluctl, Kluctl. Anything else you want to add there?
I would say just laid into the hands of the community. I don't even know how to call it. So Kluctl is fine, Kluctl is fine, everything is fine.
Kluctl. Let's go with that one. All right.
Yeah, great.
Could you please before we start talking about Kluctl, just take a moment to tell us a little bit about you and what you've been up to, please.
Yeah, my name is Alexander Block. You can also call me Alex or Coda Block when I'm online. So same handle used on Twitter and GitHub. I'm a senior DevOps engineer, backend developer, software developer. I'm a consultant, freelancer. And I'm very excited about open source development. So I'm trying to do that whenever possible. I'm trying to contribute whenever possible. And Kluctl or Kluctl, yeah, we decided to call it Kluctl. It's kind of the first big project that I started from scratch, and which is kind of my own baby right now. So yeah,
Awesome.
that's me.
Thank you for sharing. Maybe you'd like to give us the quick TLDR of what Kluctl is. Now, I know we're going to have some slides, so just give us like the 30-second kind of pitch. Like, what is Kluctl? What's the history? Why did you start building this thing?
Yeah. I describe it as the missing glue. So that's where the name comes from, by the way, Kluctl with K instead of G and without the E. So glue, whatever. It's the missing glue between tools that already exist, for example, Helm and Kustomize, and it's kind of a front end to these. It allows you to define multi-environment, multi-cluster deployments, and it has a CLI to control these, or actually to do the deployments, do diffs and dry runs and so on. So yeah, that's Kluctl. And in these slides, I will try to explain how it came to that tool and what the reasoning behind that is.
All right, without further ado, let's hand over to your slides then. If you want to get them ready, I'll pop the scene over. And as always,
Mm-hmm.
to people watching, please feel free to add any questions that you have throughout the session into the chat and comment box, and we will do our best to tackle them.
Great.
Alexander, your slides are now live. Take it away.
Great. So I assume you can see the Kluctl logo.
We can indeed.
Great. So let's start. So just small agenda for the slides. I'll try to make it as short as possible, so not so much slides. The hands-on is the most important stuff that comes later. So who am I? Just why another tool, introducing Kluctl, and then the actual hands-on. I already explained who I am, so I think I can skip it. Let's go to why another tool. So I've been working on many deployment projects in the past. It started with plain Docker, then Docker Compose came, and Docker Swarm, and later Kubernetes. And it turned out that every one of these projects had the same requirements and same problems to be solved. In the next slides, I'll try to give an overview of these and describe why existing tools did not solve them. It won't be the focus, but I'll try to do it kind of in between. So, of course, one of the most important requirements is infrastructure as code. So everything 100% must be as code, meaning it should be part of version control. And yeah, so it's so that you don't have to type in kubectl all the time and recreate everything by hand. I prefer declarative code whenever possible, but there are still situations where imperative parts are still needed. As an example, having declared everything is good, but in the end, you still need to adhere to deployment order, for example. As an example, you have to deploy a namespace before you can deploy any other object into the namespace. So that is kind of a mix of declarative and imperative. It must be fully automatable and reproducible. And for me, it was always important to at least allow the coexistence of GitOps and DevOps in a seamless way. I'll explain that later a little bit. Another requirement is I always needed to have to support multiple environments. So it's not enough to just have a bunch of YAML files and just deploy them to one cluster and that's it. That's not enough. We always have multiple environments. We have test, we have dev, we have production, and so on. These are not necessarily on the same cluster. They are actually quite often on different clusters. So you have a prod cluster, you have a test cluster, and so on. At least in my opinion, should always be the target to have as much parity as possible between environments. So they should look like the same or at least have the same source and shouldn't have that much differences. In practice, that's not always the case because, for example, if you deploy something on your local machine, you will probably not deploy all the monitoring stuff while you would deploy that to prod. Next requirement is it's always required to have proper secrets management. I prefer version controlled encrypted secrets with public key encryption. And it always turns out that there are nice tools to do that, but the hard part, which is key management and actually encrypting the correct secrets with the correct public key for the correct cluster is actually the hard part of that. So next thing is deploying some environment, for example, dev, to a prod cluster by accident should be impossible by design. What I mean with that is if I, as a DevOps engineer, want to deploy something to dev, I shouldn't have to figure out what context to use. I shouldn't have to figure out what other credentials are required. I shouldn't have to figure out what configuration I should choose to deploy to dev. My deployment should itself define what dev is. So what the environment dev is, what it means, which cluster it is, what configuration, and so on. That means environments must be a first-class concept. That's a requirement that I had for myself all the time. Next, by the way, if you have questions in between, just stop me and ask them whenever you want to, or comments or whatever.
Definitely.
Also when comments arise or something like that. So next topic, configuration management. To meet the previously described requirements, some form of configuration management must be possible because environments differ in all kinds of variations. There are simple variations. For example, prod needs another database than dev, and it gets more complicated when, for example, your local deployment doesn't even use an external database, but wants to deploy its own database because it doesn't have one externally available. Yeah, and then there are other examples. For example, if you have a test environment, it might be useful to deploy a mail interceptor, something like Mailhawk or Mailhawk, I don't know what it's called, while you never would like to deploy that to prod. So that gets a little bit more complicated in regards to configuration management. So in my opinion, templating is a must, and I believe that overlays are not enough to solve that. You can solve most of that with overlays, for example, with customized overlays, but it will get hard and feel unnatural if it gets too complicated. At least that's my personal experience and opinion. Next requirement I always had is I want to move fast. I'm a very impatient DevOps engineer. Stuff must happen immediately, and I must be able to change stuff as fast as possible with the security or the confidence that what I do actually results in what I want to do. For that, I need a proper logical project structure that feels natural. What that means is, so if I open my project in 2 weeks after I closed it today, I must be able to immediately understand it because it's kind of natural to the way I think and how I structure my stuff. If, for example, something is based on customize and overlays, I often got to the point where it didn't feel natural anymore. And understanding my own stuff was very hard after some time because that's not how I think. Yeah, boilerplate that doesn't add value should not be present at all. At least that's what I believe. If I just want to add one YAML file in just one resource, and that's all I want to do, I don't like to add too much boilerplate to just do that. For example, adding a Helm chart just to add a small module that adds one YAML is too much, at least in my opinion. Without the requirements met from above, refactoring and high-risk changes are no fun, which usually leads to not doing refactoring and not doing high-risk changes, or at least postponing them forever. Then I'd like to avoid push and pray workflows as much as possible. So when I remember my first days as a DevOps engineer, one thing that was the most not fun part was to do a change, commit it, push it, and wait for Jenkins, GitLab, whatever to finish a pipeline. And just after a few minutes knowing that my change was actually broken, and then redoing the same workflow again and again and again. So that means I want to develop locally and I want to test locally. And I mean everything. So I must be able to completely verify locally that my deployment will actually work, no matter how simple it is, no matter how complex it is, no matter how small or large my change was. Based on that, day two operations should be supported in some way, or at least made easier. That means I must always be able to determine the current state of my deployments. So not just look at Git, for example, and see, okay, that's the state, how it's defined. I must also be able to verify that this is really the state of the cluster. GitOps kind of allows that, but not in all cases. And if you want to mix DevOps with GitOps, then you need other ways as well. Next thing is I must always be able to predict what consequences my changes will have. That means if I change a Helm value, for example, I must know what consequences that change has. Just looking at the changes in Git will just tell me, for example, that one value has changed. But the templating behind Helm might result in very big structural changes of whatever I deploy. And I must have a way to actually see these changes, for example, by having a dry run being applied and then seeing the logical diff or the structural diff. Then I must always be able to determine what consequences my changes actually had. So even if I assume that this will happen, I must later be able to verify that it happened. That means I want diffs, 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 and much more diffs, and not just git diffs. So basically that means what I just explained. A change in a Helm value does not reflect what really will happen. I want to have a full diff of the state before and after my change. Yeah, if these requirements are met, I think that DevOps or the daily business as a DevOps engineer becomes a breeze, because you get into a point where a change doesn't make you paranoid or cause fear and kind of make you avoid doing changes to prod or something like that. Yeah, opening the gates to hell. All the available tools on their own were not able to solve all these requirements in the last few years. It was always required to do some kind of deployment orchestration, or glue code, as I call it. And from my experience, it always starts like, it's just a few lines of bash. Let's start with the deploy.sh, tell it which environment to deploy to, and then we're happy. I'd say 100% you'll wake up in hell after some time. So at least use Python or maybe a dedicated tool that solves all this. Yeah, so next one is actually introducing Kluctl. Do you have any questions or comments so far?
I would say that based on what you've described, Kluctl is promising a lot, and I'm quite excited to what we're going to see in this definition. I think you've touched on a lot of really valid concerns, like
Yeah.
especially the Helm one resonates well with me. I've been in that position before, where you make what you think is a superficial change to the values.yaml, and then you end up destroying the entire deployment in a production environment, or maybe even not production, but still an important environment, because prod isn't the only one that important.
Yeah, in the end, every environment is important, because if it causes you extra work to fix what you just broke, I mean, you've lost time that you could have spent in
Exactly.
different,
It
better
could be
way.
QA, it could be staging, it could be performance, it could be
Yeah,
pre-prod. Like all of these environments need care and
exactly.
attention. And yeah, I don't like being the one to break it. So, and
Yeah,
I've done it before with a Helm values thing. It's something again trivial. Oh, I'll just change this one parameter, but actually the repercussions of that lie
yeah,
deep and cascade down all the other deployments. So,
yeah,
I'm excited to see what Kluctl is going to bring to kind of bring that under management.
yeah.
So, no
Um,
questions right now, but a lot of excitement.
that sounds good. That's a good start. Maybe to get more into that point with Helm. So when you're using Helm, and like you're using a lot of Helm charts, you of course have to maintain the used Helm charts in the form of doing updates and pulling in changes or new versions and stuff like that. And so without proper tooling, you are kind of blind. You see, oh, there's a new Redis release. Let's pull it and deploy it, and we are happy. The problem is, Redis is a good example. At some point, they changed, I think, slave to replicas in the deployment mode, which meant that your existing configuration was invalid because you were still using the old naming for the deployment mode, which would completely break your deployment without you having changed any of your configuration. So what you actually need is you need a way to dry run or do a diff um, for the changes that you just did, or if you do Helm updates and stuff like that. So I can say that the projects where Kluctl is in use, we have no problem with Helm updates at all. We do it once a week. We go through all the projects and update dozens of Helm charts every single week. And we are completely confident that it will not break stuff, because if it will break stuff, we will know it before it breaks stuff, because we just see it.
Yeah, there's a cool, slight segue, but just because we're talking about Helm and changes, it's like one of the challenges is that when you pick up a new version of a Helm chart, you really don't know what's changed, and you don't know
Yeah,
what's changed in the templating. You don't know what's changed in the schema for the values file, although they are
yeah,
trying to make improvements there. Um, and something I think is really cool that we should take away from the JavaScript ecosystem, and maybe something that Clue Control does, and I don't know, maybe I'm hitting on it, but is the ability to do snapshot style testing where you actually take the render to YAML and then validate that on every subsequent deploy, because quite often when we do upgrades we don't really expect the templated YAML to change much, and if we do we need to
yeah.
know. So yeah, maybe hopefully that's something that Clue Control is going to do.
Yeah, it does. It does on multiple levels. So one level is the Helm integration assumes that you pre-pull Helm charts and actually put them into your version control. This has different reasons, which I will explain later in the hands-on. But one side effect of that is if you do that, you see in the Git diffs or in the merge requests that you later do to actually merge in the upgrade what has changed. If you want to, you can then go deep into the Helm changes and verify that nothing strange is happening. Or then the next level applies. If you do the deployment, Kluctl will always do a dry run before it actually does the deployment. So it will tell you line by line what has changed. So if, for example, you have a Helm chart that changes hundreds of lines of templates, but it's just a refactoring because they changed some naming or something like that, looking into Git would be not so fun because you would see a lot of changes that actually have no effect. But when you later do the Kluctl diff or deploy, you will see that nothing has changed, and you can be confident that deploying that to whatever environment you want wouldn't do any harm. So,
Nice.
as I said, multiple levels. Um, yeah. So where I'm right now? Oh, okay, introducing. Um, so after multiple incarnations of such scripts, so it always started like a deploy.sh, and first parameter was the environment name, and then internally it knew what to do, which hand charts to deploy, and which environment needs to do stuff differently, when to wait on stuff, order, and so on. After some time, I figured out that the requirements are always the same, the requirements that I just described, and that at that point, maybe it's time to have a unified solution, something that does all this in the way I would expect it. I hope that it resonates with other people's requirements and feelings, but yeah, that's what we'll discover after some time. First version was written in Python. Yeah, actually, the first version was Bash, but then I turned to Python. It was very specific to the projects that I started to work on, that I worked in the beginning, mostly for my customer and sponsor for this project. A big thanks to Helman, by the way, if these people are listening. And after some time, it got more generic and was able to handle all kinds of deployments. It was not specific anymore to what they did internally. In the end, I decided to rewrite in one last time in Go to actually have something that integrates very well into the Kubernetes ecosystem, which is not so true with Python. I mean, it's okay. You still have a lot of libraries to work with the Kubernetes ecosystem, but it's still better in Go. Current state is there's version 2.15. Next release is going to happen the next days. I personally and my customers so far consider it stable enough to be used in production. So that's about
Are you going to do one more last time rewrite in Rust?
Funny that you say that. People have actually tried to motivate me to do that. I never looked into Rust, not at all. I'm pretty sure that it's nice because that's what people tell me. But let's put it this way. Rewriting it from Python to Go was already a challenge, and I'm happy with it right now.
Awesome. Sorry, I won't distract you anymore. Carry on, please.
No, do that. That's perfectly fine. So Kluctl tries to fulfill all the mentioned requirements. It does that by have a natural and dynamic project structure. What it means will be, I'll show it later when doing the hands-on. It's mostly declarative, but kind of imperative when needed. That means we can still define the order. We can deploy a namespace before actually deploying objects into it. We can deploy CRDs before actually deploying the CRs. So many issues that I see with Kustomize or Helm or GitOps can be solved in that way by not being 100% declarative. It has native environments, so a first-class concept of environments. I call them targets because after some time I realized that you don't only deploy environments. Sometimes you deploy stuff to a cluster, which is, for example, base infrastructure stuff. And I wouldn't call that an environment. It's the dev cluster, but not the dev environment. So I decided to call that concept targets. Templating is possible everywhere, absolutely everywhere. And not really. There are one or two exceptions, but it's really minimal. This also includes Helm values.yaml. So you don't have to write 5 different Helm values files for 5 different environments. You can write one and use templating to actually do the one small change that is required to make it work on prod and test at the same time. It offers a unified CLI. That means whatever deployment you have at hand, you always use it the same way. You do a deploy for the target. So you call Kluctl, Kluctl, deploy -t and the target name. You do the same with diff, with delete, with prune, and so on. So that means if you know how to use Kluctl, you know how to deploy anything with it. I reuse Helm and Kustomize as much as possible, and they are actually Kustomize is the low-level building block. So the most low-level part is Kustomize and the resources that Kustomize is customizing. So let's stop with the presentation and actually do the hands-on.
Let's do it.
Great. Any comments, questions before I start?
Nope, we just want to see in action. Sorry,
Great.
lost my voice there. Yeah, we just want to see it in action now.
Great. I have that. Do you see
you
that
went
as
to
well? What I'm
presentation mode just so that we can.
oh yeah. I need to move that thing away here. So presentation modes.
Awesome, thank you.
And I need the console. Great. So first thing we of course need, as always, with everything related to Kubernetes is a Kubernetes cluster. I decided to just use kind. Let's start with a single kind cluster. Theoretically, I could create multiple kind clusters and then show everything based on these two clusters. I'll just use one for simplicity and instead, let's say, deploy multiple environments just by changing namespaces. I could also do it with multiple clusters. Maybe we have time later and we can actually show that. Kluctl project always starts with the Kluctl YAML, actually .kluctl YAML. What this file does is it defines which targets are available. So which targets can be deployed to. As an example, let's have one that we call def. I'll explain that in a second. And one that is called prod. If you have any wishes, just tell me. Any additional targets or something like that. So I think name is obvious. It's the name of the target. When I later call Kluctl, clue control, I think I'll just say Kluctl from now on because
Yeah, go for it.
it seems to be in my mind already. So whenever I call it, I'll give it the name of the target that I'm referring to, which will be this one. I'm
So the
providing
context is just the kube control context, right?
Exactly. The idea is that the target itself is bound to the context that you want to deploy it to. So you don't have to mess around with your local context. You don't have to set it before. You don't have to ensure that you're in the correct context. The target is bound to that one. You can override it, but you normally wouldn't do that. You can also work without the context here, and then it will behave the same as Kubectl is, for example, working. Just uses the current active context. I prefer to always explicitly set the context because then it's just impossible to deploy dev to prod by accident. In this example, I'm using the same context twice. We are deploying to the same cluster, which is also fine because, I mean, there might be a test cluster running two different environments for testing purposes, or every developer has its own environment and so on. And in this case, just to showing it, just using the same cluster. So that's the targets.
I'm assuming you can enrich that with a namespace somehow for prod.
Yeah, that's what I'm going to do in the resources later through templating.
Okay.
What I can do is, let's do it now. I can pass arguments to targets. For example, let's call it arg1. And give it this one. We could do whatever we want here. Actually, this is plain YAML, so I could also do, if it makes sense, I mean, whatever. At this point, you can do pass whatever you want.
I take it those
So,
args can be consumed in a templating language.
sorry?
I'm assuming those args can be used within the templating.
Exactly.
Okay.
These args that you see here are kind of the entry point into the templating language. It is not supposed to like give this 10 pages of YAML here to configure your target. Instead, you give it the, actually, let's do it different. Let's give an argument called env type and we call it non-prod. I think that makes sense. And one, come on, arg. So we have the argument env type, and we have two flavors of it, non-prod and prod. We can give it whatever we want. It will make sense later. So the next thing that we need is a deployment YAML. This can get confusing. This is not a Kubernetes deployment. So it's not the kind deployment, it's a Kluctl deployment. And what it does is it defines other deployments. Let's start with a simple one, namespaces. So this is a list of deployment items. An item can be, or actually is always, a customized deployment. So we said we want to have namespaces. This is, as said, customization. Did I type it correctly?
I believe so, yeah.
This is just customize. You can do always everything that you can usually do in customize. You can specify resources. You can use generators. You can use patches, whatever you need. Experience shows that usually just resources is used. Sometimes patches are used. All the advanced features of customize, for example, overlays and bases and so on, you can use it, but at the point where you start to use Kluctl, you don't need it anymore. So you don't use it that often. So let's have a namespace YAML.
So why would you use a customization YAML rather than just as a retrieve straight up Kubernetes YAMLs? Like if you're not using bases and you're not using patches, would you not just have like namespace.yaml?
It's probably just because of historical reasons. Because in the beginning, this was just a wrapper for Kustomize, and then got more and more and more. I could implement that as an additional feature to just not require the customization YAML. Flux does something like that. If you specify the customization that doesn't have a customization YAML, it just treats all YAMLs as customization resources by default. I could do that as well. Yeah, I mean, one of my requirements was no boilerplate, so actually I could apply that same requirement here as well. Just
I'll open an issue.
yeah,
Don't worry.
perfect. That's what I want to see. So we have in namespace YAML. Always struggle to remember simple stuff. I think it's
that's
just
right. V1.
one kind namespace metadata names. Okay, now it gets interesting. So I could, of course, just have a hard-coded name here, but that's not fun. What we actually want to do is, let's say, demo dash, and now can't see templating. Args dot, oh no, actually target dot name. So let me describe templating a little bit. What you see here is Ginger templating. You can use it everywhere. There are one or two exceptions. I'm not going to explain them. But usually, whenever you see YAML, you can use Ginger templating. The templating context starts with this as the entry point. So you always have the target object. The target has the name context. This one is a little special. You can just use args.envtype. You don't have to type target.args.envtype. So as said, we have the target name, which is there just by default, and we can use it, for example, to have a dynamic namespace name. So everything, so whatever target we deploy, the namespace will be named differently now. And I think at this point, we are done with the most basic deployment. There's one thing that I need to add. It's a requirement. Let's go close it here. IO slash, I'll explain it in a second. There's the requirements, the root deployment YAML. There will later be more deployment YAMLs involved. The root deployment YAML must list a set of common labels which are applied to all Kubernetes resources. This is later required to do deletion and pruning of objects because Kluctl must be able to identify what belongs to the deployment so that it can actually clean up and delete stuff. So this is a requirement.
Like your equivalent or your alternative to having a state file is to add labels to the resources.
Exactly. There is no state involved at all. So in the beginning, I was like, how do I solve this? And I was thinking like, maybe I just write a config map to the cluster or something like that. But then I decided just use labels and force the user. And if I wouldn't have specified this, Kluctl would actually complain that it's missing. So
could you not just do it by default?
I was considering that, but the problem is sometimes it's possible to use deployments without targets, and then this would break if I add some kind of default logic for that. I'm still considering how to solve it. Maybe or someone comes up with a solution to that. But right now it's a requirement, and it will complain to you about that. So we now have a basic deployment. So let's do some Kluctl stuff. First thing, let's just do a deployment. Let's deploy dev first. So as I explained, I didn't really explain it, but just I mentioned it. If you do a deployment, what it will do is it will first do a dry run and then print a diff. Then it asks you, is that fine for you? You say yes or no. If you say yes, it will actually apply it. If you say no, just nothing happens. In this case, it just tells you there's a new object, and that's it. It's what we would have expected. And that's it. We have a namespace deployed right now. Let me figure out how to actually prove that something has happened. I hope everyone knows K9S.
Yeah. Can
If
you
not,
increase the font size quite a bit? It's very small.
if you tell me how to do that,
Command plus.
Command plus. Yeah, that looks good.
Two
Is
more.
that okay? One more?
There we go. I'll do. Thank you.
Okay, great. So what you should see now is the namespace. Demo dev. Great. So we see the templating value has been replaced. Great. I think it's clear. Oops, this is not what I wanted to do. I think it's clear that I can now also do.
This is the wrong
Yes,
IntelliJ.
this is Kluctl itself. I have too much stuff opened. So I think it's pretty clear. I can also do a deployment to prod now, which is the same cluster but a different namespace, and it's the same thing. And we should now be able to see, yep, there it is in new namespace.
Can I suggest some changes just because I'm curious now?
Hmm?
Can I suggest the next step?
Sure. I think the next step is to first close. What
Yeah,
is
close that one.
yeah. Where's
Just push
close?
the
There's
red
all
button.
other. So I go this one, and then file close other projects. That's
Nice.
what I want.
Okay, and
Okay.
then namespace.yaml.
Here as well, or
yeah, there.
yeah.
Can we add a label?
Sure.
I want to see how rich the diff information gets. So just call this name Rawkode. No, you can't call it name. Just something Rawkode, ABC colon Rawkode or something like that. And then do the deploy to dev again. I'm curious. We've seen new objects on the deploy, but does the diff give us more rich information as well?
Yes. So it will give
Very
you a
cool.
diff, and it will not give you a unified diff. At least for me, it's very important. Unified diff is a nice thing if you want to diff text. If you are diffing structured stuff, for example, YAMLs or JSON, you really don't want to see unified diff. What you want to see is what has actually structurally or logically changed. So you want to see the path and then the change inside that. In this case, it's easy. We added at this, it's a JSON path, we added the string.
Okay, can you apply
So
that and then we'll make one more change? Just because I always need to kind of see what happens. But let's change
yeah,
raw code
sure.
to have two R's, like a simple typo, and then run that again. Awesome. I like this.
Yeah. And it will show you this table for every object where it detects changes. So in the end, even if you have hundreds of objects, you are able to scroll through it and at least do some kind of pattern matching. Or if it's just a few objects, really go into detail and figure out what has changed.
Yeah, this is something I would find important in a pull request process. Like I want to see this diff as a comment on my GitHub or something, and just say, "Hey, this is what's about to go to your environment." So, yeah, nice.
This is something I'm working on right now, actually, to have some. So maybe another topic. There is also a GitOps based controller, the Flux Kluctl controller, which is doing GitOps style deployments for all the stuff. And I'm also working on another controller, which is not done yet. So it's not completely public yet, which will allow to kind of connect your deployments to pull requests to whatever you like. And it will do that. It will show you diffs. It will tell you if stuff is actually running and ready and so on. It will approve for you or unapprove and so on.
Okay, we have a question in the comments as well from Hugo, who wants to know whether we can now revert this with clue control. So can we uninstall production?
Uninstall production. Yeah, sure, we can delete it. It will, it's the same here. It will first tell me what it's going to do. It will delete this namespace. And now we see, wait, did I do prot?
You said dev, yeah.
You see, luckily we have a diff, and luckily we actually looked at it. So you want to delete prot. And then it tells you it will delete demo prot. And let's
All
do
right,
it.
thank you. There you go, Hugo. You can easily revert with Kluctl. I guess
Revert.
depending on what Hugo was specifically asking, I guess the change be could I revert the previous
Yeah,
change? But then that
maybe
would
he
be a
was asking about that.
that would be a get operation, though, right? That would be a get reset and then.
Yeah, if you do GitOps and or any other type of continuous deployment, then yes, you would do it through Git. Just revert the change and let whatever needs to happen happen. If you're just working from your local machine, then you would just do the change and deploy it and see in the diff if it's what you actually want to do.
Yeah, I guess because this is a entirely stateless application, there's no
Yeah.
rollbacks like we would see with Helm,
Yeah.
right? So you use
Exactly.
Git as the ability to do that.
Exactly. Even the Helm integration that I implemented, which I'm going to show later, does not use full Helm style installations, so you cannot roll them back because I'm fully relying on Git at that point. So if you want to revert something, revert it in Git and do a fresh deployment.
All right, that helps you go. Thank you.
Cool. Maybe, yeah, I'll show that later. So we have that one now. This is an interesting point now. We always had the problem, and me as well. So you did something. You deployed a lot of stuff to dev, then you did something on prod, and you switched around, and then you're at the point like, oh, did I actually deploy that already to this environment? And I'm at that point right now. I completely forgot what the state of dev is. And I can just do a deploy, and now I see, oh, it's actually fine. I already deployed everything, which is a good feeling to trust the tooling and the deployment itself. I hope I made my point a little bit. Okay, what to show next? Now we're at the point where we actually want to deploy something. I'm completely open to what to deploy. Usually I just deploy pod info or something like that. If you have any idea for something that is not too complex, that doesn't need too much configuration, that would usually work with a simple Helm install, just tell me and we use it as an example.
So you're looking for a Helm resource?
Yeah, we can start with a Helm or some plain resources.
Okay, yeah, let's just do a standard deployment that deploys pod info or nginx. Either or is fine.
Okay, it's through Helm or through plain YAML?
Plain YAML. I mean,
Okay,
is there anything else you want to show in plain YAML that's different from the namespace example?
Yeah, maybe it's easier to just show it based on that and later go into Helm. So let's do pod info. Create a folder. We go to the root deployment again, and we just add another deployment here. So now what I explained in regard to declarative and ordering and stuff like that. And so by default, what Kluctl does is everything that is listed here is deployed in parallel. So it doesn't care about ordering. But if you realize ordering is important, and in this case, it definitely is important because you cannot deploy pod info into the namespace before the namespace is available. What you can do is you can add a barrier in between, which means do everything that is before this barrier in parallel, then wait till it's finished. Finished means it's applied. It doesn't mean it's ready. It just means it's applied. For a namespace, that's enough. And then continue with all the stuff following in parallel again. So it's super fast, but takes into account ordering whenever needed. That's what I tried to explain with the declarative versus imperative stuff. You do the same with CRDs. So if, for example, you're deploying the sealed secrets controller, you know it's going to deploy CRDs, and you cannot deploy sealed secrets before you have deployed the sealed secrets controller. So you would add the sealed secrets controller here, add a barrier, and then you would deploy the sealed secrets.
Okay.
So pod info. So we have I call it K8s deployment right now because it might otherwise get confusing with the deployment YAMLs. I cannot remember how a deployment looks like. I always have to copy
API
paste it.
version apps/v1.
No, I really don't want to type out the full Nginx deployment now or pod info deployment.
But I've got it all
Wait.
down by heart. Like that's the only flex I've got.
Hmm? Sorry, I didn't get it on
It's all right.
acoustic.
I'm just being silly.
Okay.
Please feel free to copy and paste the deployment.
Yeah, should have prepared one. There is one.
Matthias in the comments is looking forward to seeing the Helm. So we'll get to that in just a minute.
Yeah, I'll try to speed up with this one. So I found an Nginx deployment that's so. Do you know if pod info is available as a Helm chart, right? So maybe we do it the other way around. We start with Nginx. So I'm just using this deployment. I'm not going to add a service now. I'm not going to add ingresses and stuff like that. We're just going to ignore that. But we need to do a few things. We, of course, have to deploy to the correct namespace, because otherwise it would be default. How did we call it? Demo dash target.name.
Yep.
Yeah. Let's start with one replica. Everything else should be fine. I'm not going to do any configuration or stuff like that. I don't even know what it will show if nothing is deployed. Maybe some hello or something like that. But that's fine. So we need a customization again. I'm doing some copy paste now. And I think we are done. This should be the basic. Yeah, Nginx deployment. Let's deploy it. And it's done. And in K9s, we should see it starting up now. Pulling image. And it's running. So I said, I'm not going to deploy services, ingresses, nothing like that. I'm just using the port forwarding feature of K9s. I said, who doesn't know K9s? Really, you have to get to know it because it's just great. So we have localhost. Oh, come on, host 8080. And we have Nginx running. That's great. Okay, I think that one was quite easy. Maybe before I start with the Helm part, I do some more in regard to configuration and templating. The deployment YAML also defines which variables are available inside the templating context. It's done by the vars key, and it's a list of vars sources. One of them is the file, and it's arbitrary what I put in here. So the only requirement is that it's part of the project that I'm in right now. So let's say inside vars, we have a common.yaml. So we actually need that folder. Oops, vars, common.yaml. Any ideas for vars?
You
Let's
can set
say
the replicas.
Yeah, let's do that later. So let's make the Nginx version configurable. Very important, this is plain YAML. So I could actually do something like that because that maybe is easier to maintain later. I can do whatever I want here. Lists, dictionaries, everything. And I think that's obvious as well now. So that's it. So to explain it again, inside the root deployment YAML, we include the vars file common YAML. It defines Nginx version, and then we can use it everywhere that is included from here.
Do you really consume it as nginx.version instead of vars.nginx.version?
Yeah, it's really nginx.version.
So what if I, in my common.yaml, have target : name?
I think you can actually do that, and it will override your target name. If you do that, bad idea. I'm not sure if I wouldn't if I would try to stop you from doing
Bad
that.
ideas is my middle name, I'm afraid. I always try to think of how I could break something. So.
Yeah, I mean it's your right to do that. I mean, I think I know what you're up to. What?
Yeah, I expected there to be a prefix like target
Yeah,
and args and then bars, but
yeah, makes sense actually. Maybe that's also something I should consider. Yeah, I'll think about that. And you can, of course, do an
open an
issue.
issue.
Great. There's one thing where it is already implemented this way. So everything that you pass through args inside the target definition is available through args dot. So, for example, I could use env type here. Doesn't make sense, of course, but just to show it. I'll show why the args are so nice later a little bit. So we have the Nginx version here. Let's do a deploy. Nothing should change because we haven't actually changed anything. We just did some refactoring right now. That's also what I explained before. I always want to know if my change has the expected consequences. In this case, it shouldn't have any consequences, and this verifies that it's the case. Let's say if I change this to .1, I should see it in the diff. So there we see it again. As said, it shows you the JSON path to the point where it's changed, and then it shows you the unified diff, which is a very short one.
Can you open the Kate's deployment.yaml, please?
Yes.
Can you remove the namespace from the top and then run deploy again?
It's actually a good idea. Let's do a little bit different thing. I'm going to deploy that to prod now, okay? It doesn't make sense, but who cares? So I think this is what you're targeting, that it's going to the default namespace right now. Let's assume we did that by mistake. We completely forgot that we had to actually set the namespace. And we deployed it to prod. Now we realize, oh, what have we done? We deployed something to the wrong namespace, and we have to fix it. Now the naive solution is to just add the namespace and assume that this has fixed it. But if you deploy that, it doesn't just change the namespace. It actually means I'm deploying a second version of that same deployment to another namespace because the old one is still there. I think that's what you were.
Yeah, I wanted to see how it identifies the replace.
Yeah. So what it will show you now. This is something it's in my head which needs to be changed. So let's do diff. A diff will basically just show you that and show you often objects as well. So it tells you what you actually do right now is you create a new deployment, and then there is an often object, which I don't recognize anymore, but it looks like it was part of my deployment in the past. What you can do now is you can deploy it first. In this case, you just see new deployments. It doesn't show you that there are also often objects. After deployment, it will show you the often objects. So this is something I need to change to actually show that before as well. So what we have now is we have that same deployment two times, once in the correct namespace, once in the wrong namespace. If your tooling doesn't support you properly, you might end up with garbage all over your cluster because of such things happening, and you wouldn't realize it. With GitOps, you can do prune. You can enable pruning for your deployments, and it will handle it. But if you're not using it, you will end up with completely.
Okay, before you prune that, can you go back to K9s? Something
Yes.
odd, right? Is that replica set ID is the same on both. How did that happen?
Replica is what? One?
No, the replica set. Can you run look at replica sets in K9s across all namespaces? 75658D4777 and two namespaces. That's pretty
Oh, this is
weird.
really strange. Now I know what you mean. This is strange.
It is strange.
would be
Must be something
interesting
that
how.
must be something to do with the deterministic nature of the replica set and how
Yeah,
these are created across. That's I've never seen that before. I'm going to have to dig into
yeah.
that.
I actually never looked into at that point, but you're right. It's interesting. So there must be some deterministic way to figure out the names that it uses internally.
Yeah,
It's
based on
interesting.
maybe the revision ID, the generation, and the hash of the object.
Yes,
Which
some
means you
hash of
could
something.
probably do some. This is not
And
an
I
episode of
think,
clustered, but I'm now working out ways that I can do collisions across clusters. But that's
yeah, but I assume it's still fine, at least inside the same cluster, because it's still namespace. It's still in different namespace. But yeah, let's get back to, okay, so here we have the pod. So you of course don't want to have that garbage on your cluster, and you want to clean up immediately when you realize that situation. What you can do with Kluctl is just do a prune, and it will delete the objects that it determined as orphan.
okay.
Say
So we have a
yes.
question in the chat from
Mhm.
Matthias, and it's something I was thinking too. But they were, I'm assuming they maybe are familiar with the tool, but they're asking if there's an override namespace and a deployment.yaml, which is, I think is a good question because I would
Yeah,
probably forget to specify the namespace in a resource at some point. So can that be?
I yeah, I think that's Matthias. I think I know him, and yeah, he's quite familiar with it. I think what he wants to ask is, so as we are using Kustomize, we could, of course, also say that we tell it to use this namespace at this point.
Mhm.
So this is one option to avoid such situations, just using Kustomize to set the namespace. I think it's clear what I'm going to do here, right? Demo and so on. I'm not going to do that now for the demo purposes. Another option is inside the deployment YAML to also say override namespace and basically do the same. So demo target.name. It would have the same if. Not exactly. So what override namespace does is every Kustomize that it encounters that doesn't have a namespace set will get that namespace. So if a customization still says, I want to deploy it to Blob, it will still be deployed to Blob because override is only happening if it's not set. But I'm not, I'll not go into more detail in that regard if that's fine for you.
Okay.
Okay, where did I stop? So I think we were here with the bars. So I included a common YAML. That's not very interesting. It's nice, but it's not the most important thing. You remember that I said that the args from the target are more like an entry point to the configuration. Because if you would write down all the configuration that is required for one environment, it's easy to end up with pages of just YAML inside this YAML, which would make it hard to maintain. So instead, I tend to use it just as an entry point. For example, env type, there's prod and non-prod. And what I can do inside the deployment YAML then is, as I said, templating is possible nearly everywhere. I can use that to define which file to include. So what we can do now is have a prod.yaml and have a non-prod.yaml. What you can do now is, again, this is arbitrary YAML. And what you can do now is have the same stuff here. And for example, say replicas. For non-prod, let's have 1. For prod, let's have 3. Is it clear what this does?
It is, yeah.
Great. One thing that I should also mention is this is layered on top. This means first this one is loaded, then the template context is enhanced, then this one is loaded, having this included as well already. So I could theoretically use nginx.version here already. It doesn't make sense right now, but I could do it. So I can layer one on another and kind of do all kind of fancy stuff with that. Then another thing is if one vars file has the same defined as the one above, for example, we have replicas here, it will overwrite this one value. So it does a merge of the YAML files. So what we can also do is, let's say we don't define anything for non-prod. So the default is to have replicas 1, but for prod, we have some special configuration which says override this value with 3. Is that clear so far?
It is.
Great. And I think it's obvious, we just use that value here. And let's do a dev deployment first, because nothing happens, which is expected because we didn't change the replicas, right?
Mm-hmm.
But I completely forgot that it's actually expected to change nothing, but luckily my tooling is helping me. For prod, it should look different. And something is wrong.
Because you did a prune.
Oh, yeah. That's what happens if you use history too much. So, and it tells us that there is actually a change for prod. And we say yes, and we see more replicas, which we expected. Great. I assume that this feature with the vars is, I think it's clear, right? What this is all about. Very important. This is a list of vars sources. File is just one type of vars source. There are other types, for example, HTTP. You can do an HTTP request and load some YAML from the web. You can load something from some GitLab repo.
Does that
whatever.
work for deployments too, instead of path?
Yes.
Awesome. Okay.
Say git include, but I'm not going to show that now because that would require Git to be set up with repos and stuff like that. So you then also give it the path and so on. What else? Vault. Vault is experimental. We have HWS Secrets Manager. And what else? Cluster config maps. This is also very interesting. I think it's namespace, name and key. I don't remember exactly which ones need to be specified, but what you can also do is while you're deploying, it's loading something from the cluster, using that as variable source, and then you can use it inside the templating.
Yeah, that just got a lot more interesting for me on a personal level. I do a lot of conference talks, and one of the ones I've been given a lot over the last 2 years is to talk about GitOps and how actually overlays are an anti-pattern because we encode environmental information into our application deployment description, when really our application shouldn't actually know the environment exists. The environment should provide everything it needs. And with this cluster config map option, we actually provide a way to say, here's enough information to deploy and get everything else from the cluster itself. Like that to me is a killer feature.
Yeah, it is. We use it as an example to provide, so what we do is we have a kind of a cluster-based deployment, which is a Kluctl deployment, which contains ingress controllers, gatekeeper, Cilium is deployed, and like everything you need to have a usable cluster. So you start with a naked cluster and you provide it with everything that you need. What we also deploy as part of that is, actually one step before, when we create the naked cluster through cluster API, we also deploy a config map containing information about the low-level infrastructure, for example, networking, which subnets are used for the cluster and stuff like that. So it's just a config map. Every cluster has that. In the end, the base deployment can then use cluster config map to load that config map, then get information about the subnets, which is usually a mess to get from Terraform into your deployments and stuff like that. So in this way, it's quite easy. And then we can use that information to configure Cilium properly to use the correct subnets. and so on. I think you understand this, you can do a lot of
Yeah.
stuff with that. There's also the cluster secret, which is basically the same, just for secrets.
Okay. We've got just over 20 minutes left, so I think we should get onto the Helm stuff and show that.
Oh yeah. Okay, then, so I think we described everything related to that. Okay, so let's do something different. This is very important. I'm not going to directly include the Helm file. I'm going to add a sub-deployment, which just contains a deployment.yaml, which is the same as this one from the idea. And what you do here now is, instead of paths, we say include third party, and this one starts with deployments again. And here we have, again, a customized deployment, and we call it pod info. I know it's Helm, but internally, customize is used to actually deploy Helm. It will get clearer in a few minutes. So we have the pod info. And now we have the customization YAML, resources. Ignore that for now. I'm going to explain it in a minute. So now the Helm integration. Now it gets interesting. So for the Helm integration, we first specify which Helm chart we actually want to pull in. I keep forgetting the format of that. Let me do a copy paste. So there's documentation at kluctl.io. I hope I have documented everything that is needed. If something is missing, just tell me and I'll provide it. And I'm copying from there right now. So this is the basic structure of the Helm chart. As you maybe already see, it's just a representation of what you would usually give Helm while you install something. You give it the repo, chart name, chart version, and so on. .helm.sh. So let me look for pod info. There is the pod info chart. I know you cannot see what I'm doing right now on another screen. Just doing some copy paste. So we specify the repository. We specify the chart name, pod info, and we specify the version 6.2.1. Just for demo purposes, let's not use the latest one so that we can later show how an update is actually working. We don't want to skip updates. We are happy with updates here. Release name, it's the same as if you would do a Helm install. Let's call it pod info. Namespace. Let's not forget it this time. Oops. What was it?
Target.name, demo-target.name.
This one, output. So what it internally does is it renders the Helm chart through the Helm template functionality. And then it uses the resulting YAML to write it into some internally temporary file called deploy YAML. And then we use Kustomize to actually load that temporary file. At that point, we can use Kustomize, for example, to even patch the Helm chart, which is needed more often than I like. For example, to add pod security context and stuff like that, which the Helm chart doesn't support natively. So I think that's it for now. I think I mentioned in the beginning that for the Helm integration, I do pre-pulling. That means before I can actually use that, I have to pre-pull that Helm chart and put it into my version control. I can do that by using Kluctl Helm pull. It will go through the project and find all Helm chart YAMLs and pulling it and just putting it near that Helm chart YAML. This is really just a copy of the chart itself. It means I can also look into the values YAML, for example, to figure out which values are supported. So I don't even have to go to the website and read documentation. The next step is we need Helm values. Not always, but sometimes, or actually in most cases. which is the Helm values YAML. And what you can do now, let's figure out what you can modify. We can modify your replica count. That's interesting. So let's say replica count. As we are running out of time, I'm just going to reuse the Nginx replicas now.
Okay.
It's not correct. Of course, you wouldn't do that in a real project, but for the demo, it's good enough. I think we are done. We right now have a Helm chart integrated, and we should be able to deploy it right now. Unknown shorthand. What?
You forgot dash T.
Yeah. And what you see is, this is the change that I didn't deploy. And we see a list of new objects, deployment pod info and service pod info. I'm going to deploy that now. And K9S, yeah, looks good. It's red. I assume that's normal in the beginning. Yeah, logs look good. Let's do some port forwarding. 9898. 9898. And there we have pod info. We can do stuff here. Nice. So that's the basic Helm integration. Any questions at that point? Any comments?
No, that makes sense. Like our intermediate deploy.yaml, I guess that's cleaned up by Kluctl.
Cleaned up?
Well, I don't see it.
Yeah, it's not happening in this folder because I'd be too scared to destroy something important. What I'm doing is I'm creating a temporary folder, and then I'm rendering the complete project into that temporary folder. And as part of that rendering process, I also create the templates from the Helm charts and put the temporary files into that temporary folder. So I do not mess with the actual project, which would be scary.
Cool.
So I think that's clear. And now I did a small mention in the slides that even the Helm values are templatable now. That means I can do stuff like, let's say in the vars for prod, let's say in non-prod, we have pod info, change color, true, no, let's say false. And for prod, we say change color, true. As said, arbitrary YAML, I could do whatever I want here. In this case, I'm having a Boolean. And what I can do now is in the Helm values, Jinja templating, if, how do I call it? Pod info dot change color. I can do some conditional stuff here. Yeah, don't be confused about the errors that it's showing because Jinja and YAML and IDEs, not so good friends. So inside the pod info values YAML, I've seen that you can specify a color. That's also. Let's do, I think it should support something like this as well. And done. So the interesting thing is we know that we have changed some Helm values, but in the end, we have no idea what that actually means. Because depending on how the templates are implemented, this could mean everything. And we don't know before it's deployed, usually. But with Kluctl, what we see now is we see a full diff which says nothing has changed because for def, change color is false. This is a bad example now, as I realize, because we wouldn't see a diff
Just
on
swap
prod.
them around.
Sorry?
Just swap prod and non-prod around, the true and the false.
Yeah, that's...
Keep it simple.
Exactly. So doing it again, we should see a detailed diff about what actually happened. For example, it didn't just change some value, it also added something to the deployment, which wasn't there before. And now I see that this actually had that consequence. And I can either say yes or no. And I'm fine with that change. I don't know if this green stuff really works, but I assume yes. So after some time, looks like it's already restarted. The port forwarding has to be reset. And it's green. Great. But only on dev.
So can we do the Helm upgrade to 611 as well?
Yeah. So usually you would have all this in Git because everyone uses Git. So let's create a Git project first. I wouldn't, it's not really required. I could show everything this without Git, but I'd like to show the Git integration as well when it comes to Helm upgrades. I'm doing something that I really hate, and if I ever see anyone doing that, I'll scream at him. Yeah, what is it? Oh my God. What is happening here?
It's git add dot and then git commit dash m.
Okay, git add dot.
Yep, and then you can do git commit with a message.
Commit. Yeah, well, what I'm trying to say is never add everything and commit it just without verifying what you actually committed, but that's a different story. So we have a simple Git repository now with just one commit. And what we want to do now is we want to figure out for the dozens of Helm charts that we are using, we probably already forgot which ones we are using because it's just so many. We want to just upgrade everyone. Actually, let's just figure out which ones have upgrades. I forgot it's Helm update or upgrade, Helm update. And it tells me, oh, there's a Helm chart. It has a new version available. And I could upgrade. If I decide I actually want to upgrade, what I can do is tell it to upgrade. This will do the upgrade and write the changes to the local files. But that's not enough. I actually want to have it committed as well. So it updated it, pulled it, committed it. So if you look into the logs, we see a commit that has only the specific changes related to that update included. So even if I would have pending changes anywhere else, this commit would be a clean commit just containing the update.
And do you get
So
one
later,
commit per Helm chart, or is it all grouped together?
it's one per Helm chart. The idea is that if you realize, okay, it's nice to upgrade pod info, but upgrading Cilium is maybe a bad idea right now, you can revert that one commit, for example, or just rebase and remove that one commit, or whatever you want. So you can use Git features to manage your Helm upgrades. So inside the diff of that one, okay, you can then see, oh, okay, the app version has changed. Usually you would use merge request or something like that and have a nice view of what we see here right now. But as said, you can do source level review and verify that what happens is really what you want to happen. And then the next step is, of course, because as said, in the end, it might be that there are hundreds of lines changed, but it's not affecting your deployment at all, or just changing the image version, for example. So the final step is to actually look at the diff, because this is the truth. This is what's actually going to happen. What we see here is now a label's being changed, makes sense. Version information. The image is changed, and nothing else. That looks like a easy upgrade that we just accept. And we are done. So that's the Helm integration. I've been quite fast now.
How does that work with Helm hooks? Are those supported?
Yeah, sure. Is there an example with Helm hooks? Yeah, I'm not sure if I'm able to find one.
I'm not sure if the hooks work with Helm templates. I'm assuming maybe we lose access to them.
No, it's so Helm template just writes out the same YAMLs. It doesn't care about if it's a hook or not. Kluctl knows about Helm hooks and it knows how to handle them. It knows when to deploy them, when to delete them. It knows when to wait for them. It kind of replicates the behavior that Helm does. At the same time, it allows you to have own hooks. So you don't have to write Helm chart just to have hooks. If you need to do something, I'm not able to come up with something on the fly right now.
No, that's
You
okay.
would just add annotations, kluctl.io, hook, so you have Kluctl specific hooks, which are mostly like what you know from Helm. They are just named a little bit different because in Kluctl we don't do installs, we do deploys, so it's all called a little bit differently. But if it encounters a Helm hook, it would just work as if it had been from a Helm
Okay,
chart.
nice.
So that's it. There are other annotations that change how stuff is handled. Example, conflict resolution is very important. There are cases, for example, the elastic operator, the elastic cloud operator, tends to take over ownership of fields that it shouldn't touch. For example, the node specs. And in the end, the managed fields tell you that you lost ownership of that. And you can tell Kluctl to kind of force apply whenever that happens, and to take back ownership of something that you know is yours and no one else should touch it. So you have stuff like Kluctl.io, force apply and set it to true, must be string because it's an annotation. And so there are many other things that you can use to control the behavior of your deployments. You can even do stuff like Kluctl.io delete true. It's funny because you are deploying something, but you're actually deleting something. So what it will do is it will ignore everything. So it will ignore the complete spec. And whenever it encounters delete true, just delete that object. This is sounds funny because it's maybe hard to understand why that is needed. One example is if you deploy to a fresh Kubernetes EKS cluster from HWS, you have a daemon set running there that provides the HWS any CNI, so the low-level CNI that's HWS specific. If you want to use Cilium, you don't want to have that daemon set running there. It must be deleted actually. And to avoid having manual steps to deploy Cilium, you can instead have a dummy daemon set that has Kluctl delete set to true, and then that object is going to be deleted. You can also do that as part of the deployment YAML. So you can, and then it's, so you specify how to identify it and namespace name and so on. And so it knows that at that point, it should just delete that object.
Nice.
Okay.
All right,
Yeah.
we have 5 minutes left. Is there
Yeah,
anything else you want to cover, or should we jump back to big face mode and just chat for a few minutes?
It depends. If you have any ideas, any questions where you think it should be shown, just say it. If not, we can just go to the face-to-face mode again.
Yeah, let's jump back because
Okay.
you've covered a lot there.
I can cover a lot more if you want. It's, I mean, deploying to Kubernetes is a complex topic. That's a fact.
It is. What I loved is every time I thought, oh, how would I handle this use case, or how would I handle this? It's like there was a way to modify and change that behavior, even down to that last example there, where we have either the ability to apply a dummy resource with the delete annotation, but even in the deployment spec, just to have the delete objects as well. So like yeah, I'm pretty sure this could probably handle any complex deployment that I was going to throw at it, which is quite exciting. So.
Yeah, we have very complex deployments, and we actually deploy everything with it right now. One question in between: am I still sharing, or are we in face-to-face mode?
We're in big face mode.
Okay, then let me open. Where is it? So that I can see you as well. So no, okay, I can see you as well. Great. So what was the question? Sorry.
There wasn't a question. I was just really happy that I was in my head as we were walking through going, oh, I wonder how I'd handle this situation. The EKS one is a big one, like the EKS ships with a bunch of default resources by default. You either need to modify or delete or replace, and the hooks are there to do that. If you're working with Helm charts, you've got the ability to template the YAML, the values file, but not even just that. It supports all the hooks. And then Kluctl has its own hooks. So if I need to do more things, then I have access to that. Like, it's a really powerful tool, and something I think I'm definitely going to have to experiment with. And I always say my production, but it's like my production. It's my cluster that I do all my YouTube automation on, and all my website automation on. So, yeah, this is a really, really cool tool. And I can see from all of those features that you've added, you must have been working on this for quite a long time.
Yeah, as I said, it had multiple incarnations, so it was not immediately in that state. For me, it's very important to reduce the set of features to a minimum and not have specific features. Like in the past, there was a lot of stuff to handle environments correctly, and then I realized I can do all this with templating. So I removed a lot of features and just stick to the base features. I mean, it's still a lot, but yeah,
Yeah, I think I personally, I don't think I would use. I don't have one target, and I would use that config map from cluster to do all the environment enrichment. That's the thing that I'm most excited to experiment with as I start to play with Kluctl. So
you can mix it. For example, you could decide to use targets just to targeting a cluster, and then hand over to the config map to get in the actual configuration. So you have.
But if I use it as a GitOps style environment, I don't really need the targets, right?
Yeah, and long term. So I'm working on that right now. The next release, the 2.16, will actually improve that you can do targetless deployments, which will then kind of behave like kubectl would do, deploy to the current context. And
yeah, to me that's a really interesting paradigm because it removes more boilerplate, it moves more logic into the cluster, and it simplifies the deployment manifest from the developer point of view. It's like the environment will decide how many replicas or how the HPA should function or what the Enger's domain names are. The developers really shouldn't have any control over that because they're not the ones responsible for providing the environment in which the application runs. And I think Kluctl, I mean, I've tried to do this with Pulumi and CDKs, but what I'm seeing from Kluctl gives me a simpler declaration, and that I'm just working with YAML, Kustomize and Helm, tools that are almost ubiquitous to this point, but I'm able to enrich them with the behavior that I need with the templating. And I think that's really interesting. So I'm definitely going to be kicking the tires on it. So please expect a lot of issues on the GitHub as I fumble my way through it. And maybe I'll just have to reach out and be like, I need some help. And maybe we need a second stream to cover all the other features that we haven't even covered today. So
yeah, I can do that. The good thing is, I mean, the project I'm working on it still since quite some time, but I've not been publicly active in the beginning. So that's what I started the last few weeks or months. That means the user base is still, let's say, growing. The advantage of that is that if you have feature requests or whatever, right now it's still easy to get me and to get me actually helping you immediately.
Well, yeah, people can go to the GitHub page where you can file issues. You are also in the Rawkode Academy Discord, so if people want more real-time communication, I'm sure you'd be okay. I hope. I'm just going to assume you don't mind people tagging you, and maybe we'll even create a channel for Kluctl there, just so if people do want to chat in a real-time fashion, it is available. But I've been really impressed with what I've seen, so I'll say thank you for working on this. I think it's a really interesting project. Like I said, I'm definitely going to try and kick the tires on this for my production infrastructure, and maybe I'll even submit a pull request. We'll see.
Happy to hear that, and thanks for having me.
All right. Well, it's been a pleasure, Alexander. Thank you again. Thank you to the people watching at home or watching after the fact via the power of YouTube. We'll keep you updated on my adoption of Kluctl, and we'll be back again in the future. Thanks a lot, and I'll see you again soon.
Bye. Bye-bye.
Thank you for watching Rawkode Live.